Bismillahirrahmanirrahim. Assalamu alaikum. Today we are going to start the lecture number 20, and during this lecture we will discuss about conditional and block structures. So before going to start this lecture, we will see what we did in our previous lecture. 19 lecture में हमने discuss किया था about IO instructions like std-in and std-out procedures. So you can see here the syntax and the example of the std-in and std-out procedures. Then we discuss about the conditional jump instructions like jumps based on the specific flags, and just like the jump carry, jump 0 and so on. There were different conditional jump. And then we discussed about equality jumps like jump equal, jump not equal and so on. Then signed and unsigned comparison, just like jump above, jump below, and jump greater than and jump less than conditional jump instructions. Here you can see there are different conditional jumps like jump when below, jump carry, they are almost similar. Jump equal, jump 0, jump sign flag, jump not equal, jump not 0 and so on. And also in that lecture we did all these instructions inside assembly language. You saw the programs where we use all these IO and the jump instructions. Now we are going to start with this lecture. In this lecture we will discuss about the bit test instruction, how we can test single bit inside the any expression inside any register or any variable and so on. Then we will discuss about loop, but loop instruction, the conditional format of the loop instruction, like the LOOPZ, LOOPE, LOOPNZ, or loop not equal 0, or loop not equaled. So these are the conditional loop instructions that we will discuss, and we will see how we can use those instructions in assembly language. Then we will discuss about the block structures. Here inside block structures we will discuss about the if block structured if statement, then compound expressions, how we can use those compound expressions like and or expressions. When we have two expressions like if A is greater than B and C is greater than B or something, so we have two expressions and we combine them by using and or operation. Then we will discuss about the while loops and the repeat loops. Now first of all, bit test instruction. Now this bit test instruction, what does it do? This bit test copies the bit n from the operand into the carry flag. Now here you can see the syntax of this bit test. So the opcode is BT, then we have the bit base from where we are going to test the bit, and then the bit number. So here this bit base may be register or memory. So this can be a register or memory of 16 bits or register or memory operand of 32 bits. Now n specifies or n may be register 16-bit, register 32-bit, or immediate value. For example, we have register or some value inside the memory or somewhere else, memory or register, so it can be here 32 bits, or we can have 16 bits. So we want to test the nth bit here, any bit like this one is either 0 or 1. So we specify the location of the bit, and then this bit will be copied inside the inside the carry flag, inside the carry flag. So this is the statement you can use to check either this bit is 1 or not. So how we can do, for example, you can see the example here. We write jump to L1 level 1 if bit number 9 is set in the AX register. So here BT, this is the base, bit base from where we in which we want to check either its bit number 9 is set or not set. So whatsoever the bit number 9, its value will be transferred to the carry. Now here, if you want to check either this bit is set, then we will write jump carry. If you want to check either this bit is not set, or if you want to jump based on the carry, for example. So there are two instructions, jump not carry, NC or jump C. So it depends on your logic how you want to use this one. So sorry, this carry here, actually this is at this place, so this is a comment, it has come at the next line. So actually the code is only 2-line code here. So whatsoever, if the L1 is somewhere else, here is L1 or the label 1, if the 9th bit of AX is 0 or 1 whatsoever, it will be transferred into the carry, and we can say jump carry. If the carry flag is set, then it will jump to the L1. So here you can test any bit inside the and bit base. So this instruction is if you individually want to check the bits, their values, either they are set or reset inside a register or a memory location of 16 or 32 bit. Now we will discuss about the LOOPZ, and these are called the conditional loop instruction. Now previously we discussed about the loop instruction, and we know that inside the loop instruction ECX register have been used. So ECX register defines the count, the counter. For example, we assign some value inside the ECX, and ECX register, what will happen, every iteration, during every iteration ECX is decremented. So ECX is equal to ECX minus 1 and so on when we every time when we execute the loop. Now here these are the conditional loop instructions. Alongside with this ECX, we are checking other conditions like the carry bit or equality bit, 0 bit and the equality check and so on. So here we will see what is the condition or what is the logic behind LOOPZ and LOOPE and LOOPNZ and NE. So LOOPZ or loop equal, they are almost similar. How we can use them, what is their syntax? So here you can see syntax for the LOOPE, and here is the destination. So we define the destination here or the label where we want to jump or where we want to loop. What is the logic behind this LOOPZ or LOOPE instruction? That every time when loop executes, ECX is decremented. This is common. This is for every loop instruction. And loop will jump, or the jump will be performed to this destination or to this label if ECX is greater than 0 and 0 flag is equal to 1. So if these two condition matches, because we know that if ECX is equal to 0, then loop will terminate its execution. But here, if the ECX, and it will jump to the destination if ECX is greater than 0. So here, this is a necessary condition, like if ECX is greater than 0, definitely it should be greater than 0 to perform the jump to some predefined label, or the condition that loop will terminate definitely if the ECX is equal to 0. So first condition should meet, that ECX should be greater than 0, and then the second condition is that 0 flag is equal to 1. If the 0 flag is set, then it will jump to the destination, otherwise it will not jump to the destination. Now here you can see it is useful when we are going to scan an array. For example, we have an array of elements. There are multiple elements inside an array, and we are scanning, for example, element number 0, element number 1, 2 and so on. We are going to scan all these elements, and for the first element, so we are scanning an array, and for the first element that does not match the given value, that does not match to the given value, so we will match 1. If it doesn't match, then, for example, if it doesn't match, then it will continue. So it will continue until the first element matches. Okay. So here you can see the other one for the loop Z NZ or LOOPNE is a conditional loop instruction, definitely it's conditional, and then the syntax is almost similar, but the logic behind this one is if ECX is greater than 0 and 0 flag is equal to 0. So when we know that when two values are equal, not equal, then 0 flag is 0, and the condition for loop itself is when ECX is greater than 0, then it will jump to the destination. So here it is like it's useful scanning an array for the first element that matches a given value. Now here you can see the example, for example. So in this example, it will find the first positive value inside an array. So here you can see the first value is -3, then -6, -10, -10, or -1 and -10. Then this is the first positive value. So the main objective behind this loop NZ, for example, is it will find the first positive value, not the negative. So you can see that when the first value will meet, it will exit from the, or it will quit from the loop. What is the logic behind this one? So array is the signed word, and sentinel is a variable, for example, a variable, or it has the signed word 0, its value is 0. Now what we are going to do here is ESI, definitely we have the offset of this array, the starting address, and ECX has the length of array. Why we have ECX total length? Because we want to traverse whole array. So ECS must have the value 1, 2, 3, 4, 5, 6, 7, and 8. So ECX should be equivalent to 8. Now this is the body of loop from here till here. Now in this body of loop, what we are going to do is we want to test either the first element is, we will find the elements or compare all those elements until unless we do not meet with the first positive value. So here first one is test. We are using test statement. What will this test statement will do? It will move the test bit, or test we are going to test the sign bit. So it is moved with the 800 in hexadecimal. Now we know that the first ESI value, whatsoever the value is stored at this position, whatsoever, for example, initially the first value will be located or pointed out by this ESI, because ESI is the starting address. Now why we use 800? We know that we want to test this bit. So 1 0 0 0, this is for 8, then for 0 all these will be 0, and so on, then 0 0 and so on. So we want to test if this bit, if we use the test one, if this bit is negative, definitely if the value is negative, then this bit should be 1, because this bit shows the minus sign. So before that one, what we do, we push the flag, all the flags on the stack, and we add ESI with the array type, what type of the array. So it is, for example, if it is signed words, and that it will be 2. So 2 will be added inside the ESI. We are incrementing. Then why we are saving all these flag registers? Because when we perform addition, then it will affect the flag register. So before that one, we are going to push all these flags. Then again we are going to pop. Now we have incremented this one, but after that we pop this value of these flags. Now we want to check either the 0 flag is set or not. So we will check if the 0 flag is set. It means we have found this one, because the 0 flag is set means they are equivalent to, they all are equivalent. This bit is set because we are testing with this 1 here. So if this bit is set, means the value is negative. Definitely 0 flag will be 1. If this one is negative, this one is this bit is 1, then it will give us the equal sign, or the 0 flag will be set. So what will happen here, it will compare these two, and definitely this bit is for the sign bit for the 03 is equal to 1, and then rest is the value in the 2's complement, so on. So we will compare them. If both are similar, then definitely its value will be 1. So it will jump, as we know in the previous slide, that for the n0 it will perform jump if 0 flag is equal to 0 and is not set. So we are trying to compare this bit, and definitely if this 0 flag is 0, then it will jump to the next. And when first time it will receive the positive value, what will happen? It will compare with this one, and definitely it will perform the AND operation. And the 0 flag will be equal to 1, because all the values are almost like 0. So in the end, what will happen here, if it found the first element, then it will move to the quit here. Means if it did not, if it found this one, then it will quit, and it will come here that none has found. Otherwise, what will happen? It will jump to, at this point, subtract ESI and type of the array, because if it is already found the value, then what will happen? It has already incremented 2 times or twice the size of the array, so it will jump to the address, and we can subtract the exact value. So for example, this is the another example. Here you can see that we want to locate the first non-zero value in an array. If none is found, then ESI will point to the sentinel value. So sentinel value is like some value which we assign that one. And here is you can see the example. So we have an array. For example, we have some values here. You can assign any value. There are 50 signed words, and then we have the sentinel is equivalent to the S word for 0, FFF, all these are high. Otherwise, then the code include like this one, move ESI. We have the offset of the array, and we have the length of array. So here we are trying to find the non-zero value. So first we will compare this one with the either it is 0 or not. Check for the 0. Now here in this body, you will have to write the code. What should be the code to find the non-zero value? And it should be ESI will point to this value. The solution is here. First we will push. So we have to check either if it is 0. So we are using compare, that either ESI is equal to 0. For example, if it is 0, then what will happen? The 0 flag will be high. So first we will push these flag register, then the same logic which we use. Here we will use loop equality. Loop equal. So loop equal or loop 0 will be used if the 0 flag is high. So if this flag is high, then definitely it will jump to the L1. Otherwise, it will quit from here, and ESI, if in case we have found the value, this type or this ESI will have the point or the index of the element where our first element is stored, and so on. Now we have the conditional structures. Now during these conditional structures, we have the different type of conditional structures. Block structured if statements. Then we have compound expressions with AND, compound expressions with OR, while loops, and repeat loops. So what is inside the block structure? Block structured if statement. So the assembly language programmers can easily translate logical statements written in either C++, C, or Java and high-level languages into the assembly language. For example, here you can see in C++ or C, we write if statement. For example, if operand 1 and operand 2, we have the conditional operator here. So if these two operators, the condition will be applied. This condition is the equality condition. If operand 1 is equal to operand 2, what will happen if the condition is true? In case of true, this part will be executed. In case of false, the next part will be executed. Now what we can do here, how we can convert this type of equality means statements or if statement inside the assembly language. We can achieve like this one. First we move EAX with the operand number 1, so we have the value of operand number 1 in EAX, and then we compare. What we do, we compare operand 2 with the EAX, so it means we are comparing these two operands, operand 1 and 2. So if they are not equal, for example, in case if they are equal, then something will happen. So if they are not equal, so in case, for example, if it is false, the condition which we use here in the false, if they are not equal, then x will be equal to 2, the same condition. But if this condition is fails, or in case of this one, if it is true, then if it is true, then this will happen. What will happen here in case of true? In case of true, x will be assigned the value 1. Now the next jump is here. This is unconditional jump. The logic behind this one, so we are comparing first like if statement. If here we are comparing these two. Now the checking either this condition if a is equal to 2 or not, so we can use equal also, but here we are using not equal. If they are not equal, we are moving towards the next portion, like this portion, this next portion. Otherwise, if they are equal, then what will happen? The sequential flow will continue. However, if we will not use this jump here at this point, then again move x is equal to will be performed or will be executed. So what we are going to do, we are going to perform this statement or execute x is equal to move x comma 1, then we will skip this one and start with the normal flow. So this is one way you can use, you can implement this if statement inside the assembly language. Now for example, there's a this is one example, like if EBX is less than or equal to ECX, and mind it that this is unsigned value. The values are unsigned in ECX and EBX. So we have to check the condition that if EBX is less than ECX, then what we can, the following logic will be, this code will be executed. So if the condition is true, if EBX is less than or equal to, there are multiple solutions. You can use branch equal, branch not equal, and so on. But just keep in mind, so there are multiple solution, multiple choices that you have. Either you can use branch equal or branch above or branch equal, and so on. So you have multiple choices. Now what you can use, just keep in your mind that we are using the unsigned numbers or unsigned values. So here you can see we are using jump above, because jump above, jump below, these are used to compare the to jump based on the unsigned comparison and so on. So what is the this code? This code is the equivalent in the assembly language for this C++ or C code. Here you can see ECX and EBX, they are being compared. Now after comparison, what we can use, either we can use here below or equal, jump below or equal, whatsoever you can use, but here we are using jump above instead of using that one. Why we are using this is that if condition is false, if this condition is false, means if EBX is not less than ECX or not equal to ECX, then we have to jump here, end of this code, or the next statement after this one. So that end is represented by here in this label. So if the condition is false or this condition is false, it will move here. Here in this case, if they are both are like same or both are like EBX is less than ECX, then it will not perform jump, but it will move in this direction, because if EBX is equal or EBX is less than, then jump A will not jump to the this statement or the next statement here where this label is pointing. So this is another implementation that is being that you can use. So here you can see there are multiple instructions, the same number of instructions we are using here, that EX is equal to 5 and EDX is equal to 6. So here you can see there can be another solution. For example, if I want to use the jump below or equal, for example, and so on, you can use that one, but you have to reverse the logic. You have to see that we can perform jump to that code if the condition is true. If the condition is not true, then what will happen? So for example, if the condition is true, for example, if I say jump to the ABC, so ABC starts here, and the code like move EAX, move EDX is here, and ABC2 is here. Now what I want to do here, if the condition is true, I will jump here. If condition is false, then I will perform jump to the ABC2. So it has used like more than how many statements? Compare is same here, like CMP 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4 instructions, means 5 is the next level, so one instruction is extra here. So this is the minimized one. You want to make it more concise, to make it more efficient. So there are multiple logics here. You can see there are multiple correct solutions to this problem. So we have to make it more efficient, and we have to squeeze the solution to perform the same operation to achieve the same goal with minimum number of statements or minimum code. Now for example, in case, now there you saw that one we were using unsigned values. In this case, in this example, we are using the signed values inside the variable 1 and variable 2. For example, there are two variables and they have the signed values, and this is the logic. For example, if it is true, in case of true, this portion will execute. In case of false, this portion will execute. Now what will be the equivalent code inside assembly language for this code in C++ or C? First, we will move variable 1 into EAX, the same one. Then we compare variable 2 with the EAX and so on. So what will happen when we compare with the EAX, because EAX already is the variable 1. Now jump above, jump below, they depend. Either you want to use that one, but we have used when we are comparing unsigned one. Here we are using the signed one, so we can use less than, greater than, jump greater, jump less than, and so on. All the jump instructions who use the jumps or who jump based on the signed values or signed comparison and so on. So signed jump is jump less than or equal, jump greater than or equal, jump greater than, jump less than, and so on. So we are using jump less than. Now here you can see variable 1 is less than or equal to variable 2. So we are using jump less than or equal to L1. So it will jump to the logic or to the portion where this logic has been implemented, like variable 3 is equal to 10. So it will jump, if the condition is true, it will jump to L1. So this is the condition true, L1 where variable is being assigned, variable 3 is being assigned value 10. Otherwise, if the condition is false, then we have variable 3 and 4, their values are 6 and 7 consecutively or respectively. So what we are going to do here, if the condition is false, so this is the false portion, First we perform 6 will be transferred to variable 3, then 7 will be transferred to 4. And now if we do not include this jump instruction here, the program flow will be here in this direction, and again variable 3 will be assigned value 10. That is the reason. So we want to skip this from here, we want to skip this portion and come to this point, because this logic was when the condition is true, this logic is when condition is false. So you can see here we can achieve same operation or same type of operations that we have in C++ or C or other languages where we use if statement. So same operations can be, or same logic can be achieved in assembly language. There are multiple solutions. You can implement those logics in multiple ways, but try to minimize the code or to make it more efficient. If you increase the number of instructions, definitely it will take time to execute and code will be very much slow. Now, in previous examples, we used expression, very small expression, that there is one operand and second operand. We perform logical operands like less than, greater than, equal, and so on. But we have compound expression, means multiple expressions are added in one expression. Here you can see we have first expression, then next expression, and we have the AND operation here. So logical AND operator here. So if this is true and if this condition is true, then this statement will execute. Now it means in case of AND, first this should be true. If, for example, if this fails, then definitely there is no need to check this one. So when we are going to implement the logical AND operator and consider the high-level languages, use the short circuit evaluation. So what we are doing here, in the following example, first expression is false. If the first expression is false, that second expression, there is no need to go towards this second expression. How we can achieve this one? For example, here you can see if AL is greater than BL and if BL is greater than CL, then X is equal to 1. Now first we have to check if AL is greater than BL. If it is true, then we have to move toward the next condition. So how we can do, for example, if we compare AL with BL, this is the first expression, jump A, jump above if AL is above BL, because this AL is above BL, for example. Okay, so we are assuming that they are unsigned values. So jump above if L to this L1, if AL has a greater than, okay, so where is L1? So L1 is here. Now jump to next. This is the first condition. For example, if AL is above BL, then we have to jump here to the L1, and at L1 we are trying to perform another comparison, another condition, because if this condition is true, so if this condition is true, we have to jump to the L1. So this condition is true, we are jumping to L1 to perform the next test. For example, if this jump condition, if this condition is false, then there is no need to perform this next expression, no need to evaluate. What we will do, we will jump to the next. So we will jump here and we will jump to the next. So next is here. So jump will come to here, nothing will be performed. So here in this slide, we see we'll see the example where the compound expression is being solved. So in this if statement, there are two expressions. If this expression is true and if this expression is true, then the following code will execute. For example, if AL is greater than BL, if this condition fails, for example, then in case of AND, we do not need to go towards the next expression. We can directly terminate this one. Now here you can see we have two expressions. First expression that compare AL and BL. If it is above means if the condition, first condition is true, we can move to L1. L1, here it will check the next condition. It will check the next condition. So here is the first condition, then first expression, then we have the next expression. If the first expression means if AL is greater than or if AL is above BL, then we will jump to L1. Okay, what will happen at L1? We compare BL and CL and we check if BL and is greater than or is above CL, it will jump to the L2. So L2 has the code when these two conditions meet. For example, if the first condition fails, then this jump will not happen. The jump or unconditional jump to the next will come directly here. So there is no need to test for the next condition. In case if this condition is true and the next condition is false, then if the first condition is true, jump will come to the L1. In case if BL is not greater than CL, so this jump or jump to L2 will not happen, and it will directly jump to the next label. It means again, if the second condition is true, this will not perform. This statement will not be executed. So this is one way. This is one possible implementation. It depends how efficient your logic is. Based on your logic, you can make this implementation more robust. Now here there is, for example, another implementation. So if the same condition, if AL is greater than BL and BL is greater than CL, so the following implementation, we have seen the previous implementation that we perform two expressions. If the condition fails, then it will jump to the next one, and if condition is true, if it is jump above, means if AL is greater than BL, then we have to jump to L1 and so on. Now here the same code. You can see the number of the statements are very less in this code. So the following implementation uses 29% less code by reversing the first relational operator. Now we are reversing the condition. For example, previously we were checking about if AL is greater than BL. So if jump above, we use jump above, but here we are using jump below or equal. So compare AL comma BL. If jump below or equal, if the condition is like if the value of AL is less than or equal to BL, then we can directly jump to the next. Okay, if they are not equal, for example, or not less than, AL is not less than or equal to BL, for example, this first condition is true, then automatically it will this loop will not happen, or this jump will not be performed, and program control will be forwarded to the next instruction. It will compare BL comma CL. If again we are writing the same statement, the jump BE to next. If it is BL is less than or equal to CL, it means if it is not greater than CL, so it will jump to the next. Otherwise, if this condition is true, for example, this condition is true or BL is greater than CL, then definitely this jump will not happen, both these jumps will not happen, and definitely the next instruction will perform its execution. So now you saw that in previous slide, in previous example, same thing was there, the same code, same logic was there. Here in this code, same logic will happen or same logic will be performed, but the size of the code is less compared to the previous, like 29% less compared to the previous code. So as I told you, it depends on your logic, how your logic is strong or powerful. Accordingly, you can minimize the size of the code. So for example, here is the pseudocode, the assembly instruction in C, that if EBX is less than or equal to ECX and ECX is greater than, so now there are multiple conditions here. So one condition or one expression is here, this next expression. So first expression, if EBX is less than or equal to ECX, if this condition is true, and if this condition is true that ECX is greater than EDX, this register, then this code will be performed when both the conditions are true. Okay, when both the conditions are true, then this code will happen. In case of unsigned, now just keep in mind signed and unsigned. If the values are signed or unsigned, then you have to use the logic accordingly. So there are multiple solutions. One of the solution is this one. Very simple. Just compare the first condition. We are reversing the logic. If jump above, so actually it is jump less than or equal, but here we are using jump above because this is unsigned. So jump above, jump below, and all these will be used. So jump above, if this condition fails, the first condition that EBX is less than or equal to, so if EBX is not less than or equal, then definitely this condition will be, this jump will be performed, so we will skip this one. If this condition is true, means EBX is not greater than ECX or not above ECX, then next condition will be checked. ECX comma EDX, we are comparing, jump below or equal. So we are reversing the logic. You can see here, we are reversing the logic. Jump below or equal to next. So if ECX is below or equal to EDX, means condition is false, for example, then this jump will happen. Otherwise, this jump will not happen. So jump below or equal to next. If it is true, then definitely it will jump to the next. So for example, if this comparison or this logic is true, if it is not below or equal, it means if it is greater than, it's less than or equal, for example, or below or equal, then definitely this condition will be false, so this jump will happen. But in case if this condition is true here, like ECX is greater than 0, then this jump will not be performed, and EAX and EDX will be assigned value 5 and 6 respectively. So this is one of the solutions. As I told you, there are multiple solutions you can implement in various ways, but try to minimize the code. So here, now we will test with the compound expression with the OR, logical OR operator. Previously we saw that we have the AND operator. Now we have the compound expression with OR operator. Now instead of this one, AND operation, we are using OR. The use of OR is if this condition is true or this condition is true. It means we have to check these conditions. For example, in previous cases, what happened? If first condition is false, there is no need to check second condition. Here what will happen? If first condition is true, there is no need to check second condition, because if this condition is true, either this condition fails or doesn't fail, we don't care. We don't care because this first condition is true. However, if this first condition fails, then we have to check to the next condition. So this is the only difference. In case of AND, we have to check either if the first condition is false, if the first condition is false, then there is no need to check next condition. No need to go to next condition. In case of OR, it is reverse. If first condition is, for example, true, there is no need to check. But here, one thing, if the first condition is false, then whole expression will be, in case of AND, if this first condition is false, whole expression will be false. Here, if the first condition is, for example, true, then whole expression will be true. So just keep in your mind that these are the AND and OR operations. So if we have to first check first condition, if this is true, there is no need to go for the next condition in case of OR. If this first condition fails, then we have to go for the next condition, and if this fails, then we cannot perform anything. This whole condition will be false. So until and unless these two conditions are false, it means this will not happen. If any of the condition is true, this code will be executed. So here's one example. For example, if AL is greater than BL or BL is greater than CL, so there are two conditions. So we can follow through the logic to keep the code as short as possible. So this is our main objective. First we will see compare AL comma BL. We compare these two, AL comma BL, and we say jump above. In case of unsigned, we say jump above if AL is greater than BL. So to where L1, we have to jump here. Actually move x comma 1 should be here. It has been here, so I can just remove this one. Jump above to L1. So if this first condition is true, we can directly jump here and perform the execution of this instruction here and move towards the next instruction and so on. If this condition fails, then we have to, for example, if we compare BL and CL, now it means if this condition is false, then definitely this will this statement will execute because this jump will not happen. So we have to perform another comparison, that if BL, compare BL comma CL. So if BL is greater than CL, this is the condition, but we are going to reverse that. If jump if below or equal to this label, because if it is greater than BL is greater than CL, then we have to again execute this one. Otherwise we have to move toward the next statement because we do not want to execute. So this is another way you can implement. Now here jump below or equal to the next. If I want to implement this one into the other logic, what can I do? For example, if I use the same one, jump above to L1, so it will jump to L1. But however, if it is not above, then so this is the statement here, same statement. If this condition fails, for example, again what will happen, this jump will not be taken and this statement move will be performed. So again I have to put here another jump instruction, JMP next. So if I use this jump above to L1 and if I'm not using the jump below, so I have to use another extra statement, unconditional jump to next one. So this is the way you can minimize the size of this code. This is a trick. If you want to minimize, then it's the best way. Depends on your logic. Now this was about the OR compound expressions with AND and OR. Now while loops. While loop. So this while loop is especially the format or form where you can use if statement. How we can use if statement while? If I say while EAX is less than EBX, so we have to continue this loop. So it's really an if statement followed by the body of the loop followed by an unconditional jump to the top of the loop. While consider the following example, like here you can see while EX is less than EBX, so this is a possible implementation. Actually this compare statement is here, so I can write it here, CMP EAX comma EBX. Okay, now first we have to compare and then so there's a check the loop condition. So actually this one is here. I want to, so what we are going to do here is that we have this label top, for example. First we perform compare with EX and EBX. So we have to check the loop condition. For example, if we compare, then we have this condition. So this loop will execute until EAX is less than EBX. So either I can use less than, then, or I can use above or equal. These both conditions are opposite, but I can use both. If I want to use less than, I can use less than or below, whatsoever you can call it. But I'm using above or equal. So if it is above or equal, then what I will do, I will jump to the next. So I will exit from the loop. otherwise I will increment EX and jump to the top. So this will continue until EAX is above, EAX is less than or less than EBX. Whenever it will become equal or above to EAX will become equal or above to EAX, or sorry, the EBX, this loop will be terminated. And that is the logic here, that this loop will continue until and unless EAX is less than EBX. So here, to exit from loop, the condition is that either EAX can be greater than or maybe equal to EBX, then it will exit. So the same condition. So we are performing condition here. The exit condition is implemented, that jump above or equal next. So if we say, and this is the exit condition. So this, we will exit from this loop when EAX is greater than or equal to the next. So this is one of the possible implementation. This is a possible implementation. You can have another logic. If you want to perform jump based on the below, then this logic will be different, or it will take more number of instructions to perform this execution. Now here you can see this is a drill for the unsigned. If I say unsigned 32 bits, then either you can use above, below, and so on. If I say signed one, then greater than, less than, and so on. Okay. So the logic is, example here is while EBX is less than or equal to val1, less than or equal to val1. Okay. So this is the body of the loop which will be executed in this whole cycle. And we are first we are incrementing EBX is equal to EBX plus 5, and then val1 is equal to val1 minus 1. So we are decrementing in val1 and adding the value in EBX. So at some time or some point, EBX will be greater than val1, so the loop will be terminated. So the condition to continue this loop is this one. The condition to continue. Exit condition is, what is the exit condition? To exit from this loop, the exit condition is when EBX is greater than val1. So this is the exit condition, when EBX is greater than val1. What is the implementation here? The implementation is, first we perform comparison. First we perform comparison between EBX comma val1. So when we perform this comparison, what will happen? Compare EBX and val1, jump above. This is the exit condition. This is the exit condition. So we use this exit condition here. It will exit from the loop. If EBX is above the val1, so it will exit. Otherwise, it will add 5 into EBX and it will perform decrement in val1, and this is unconditional jump. Okay, so just keep in your mind how you want to make this code efficient, and also see that either you are using signed or unsigned. These two things are more important. Now we are using the directives or if directives, for example, and so the while condition or while loop which we used, it was based on the typical or pure assembly language. Now here there are some directives. There are some directives which we will use. So we are using if directive, and also we have other directives like repeat directive and while directive and so on. And we will see what will be the output at the runtime expressions, and also with the relational and logical operators which will be used in if directive, and what will be the macro assembler generated code. And there are two additional directives, dot repeat and dot while. Now here the runtime expression is, we use if else, dot if, dot else, dot ELSEIF, and dot ENDIF. They can be used to evaluate runtime expressions and create block structured if statements. For example, Previously you saw that we were using assembly language, pure assembly language, to implement the if logic, but also in assembly language these are the directives that you can use, but however, just keep in your mind, whenever you use this if logic, then assembler will automatically convert this code into equivalent assembly language. We will see in the next slide. So how we can use this one? For example, we can write here dot if EAX is greater than EBX, then this block, or here these statements inside this one, they will be performed, else this block will perform its execution. So this is almost similar to the C or C++ high level language if statements. And here we can use also the logical operators. So these are the conditional operators. For example, if EAX is greater than EBX and EAX is greater than ECX, if both the conditions are true, then this will perform. If both the conditions or any of the condition is false, then dot else, the block after this else will be performed. So this is block structured if statement. You can use this one by using the if, ELSEIF, if, else, ELSEIF and if directives inside the assembly language. Now they perform the runtime expressions, they evaluate the runtime expressions and so on. Microsoft Assembler generates the hidden code. So this is the directive that we give to the assembler, but we already saw that for these conditions which we implemented in assembly language or the MASM will generate the hidden code automatically for you. So consist of the code labels and so on. So code labels will be assigned automatically. Compare and conditional jump instructions, all these will be generated automatically by the assembler. So first of all, you will see here the relational and the logical operators that we will use in the runtime expressions. Here you can see here the expression, for example, if we use expression 1 and expression 2, so this double equal sign, these are the relational operator. This it will return true when expression 1 is equal to expression 2. So this is not equaled, greater than sign, greater than equal to, less than equal to, mean this is the not operation. And then we have the logical operation. If expression 1 and expression 2, we perform AND. Then we have the expression 1 and this is OR operation. For OR operation we use this one, and for AND operation we use bitwise AND operation. And there are other operations like the carry. If we write if carry, if the carry flag is high, or based on these, if the carry, it will return true if the carry flag is set. Similarly for the overflow, parity, sign and zero flags. So these are the relational and the logical operators which will be used inside the dot if or the compound if directive. Here is the example what code will be generated when we execute this this type of instruction. For example, our code is this one. Now inside our code we can see here, for example, move EAX comma 6. If EAX is greater than val1, then this statement will be executed. So result will be assigned value 1. Now for this value, for here this portion, these three statements, this is the code that is generated by the assembly language. For example, it will what does it do? Move EAX comma 6 is same as this one, like these two statements are similar. Now compare EAX comma val1. Compare EAX comma val1. So here the logic was if EAX is greater than val1, then it will perform this statement. Here we are going to reverse the logic, that if jump when below or equal. So this is the reverse logic to this label. The name of this label ampersand C001. So it will come here. Otherwise, it will aid or assign or move value 1 inside the result. So this code will automatically be generated by the Microsoft macro assembler. So here you can see either you want to implement the pure logic. So this is the same logic which we already saw in our previous slides. But however, if you want to make it more simple or give it a high level language touch, you can use these .if directives and so on. So this MASM will automatically generate an unsigned jump. Unsigned jump is jump below or equal. For example, jump above, jump below or equal, and so on, jump below and so on. If you use unsigned value, then it will, because here we are using unsigned, you can see there's D word, double word, and so on. If we use signed, double word, and so on, then definitely it will use the jump greater than, jump less than, and so on, the other conditional jumps for the signed one. Now here what we have changed, you can see here, we have used the S word, signed double word, SD word or signed double word, and if I execute the same code, only I change the signed double word. Here what will happen, you can see the same, compare EAX, if EAX is greater than val1, here it will perform comparison. So jump less than or equal to, jump less than or equal to. Previously there was below and equal, so it will exit from this statement. Otherwise this next statement will be executed, like the move result comma 1 if the EAX is greater than val1. If EAX is greater than val1, definitely this jump will not happen or will not be taken or will not performed, or this statement will not be executed. So we will come to the next statement and so on. So assembler or Microsoft assembler, macro assembler, MASM will automatically convert all these directives into the respective codes. Now here you can see that Microsoft use the assembler use the automatically generated the jump less than or equal. Now in this case, for example, we are using the double word is unsigned definitely. So move EBX comma 5 and EAX with this one, and we are using this if the same one. So EAX is greater than EBX, for example, then what will happen here? So it will assign these two values to this value, the register EBX and EAX, and we compare, then it will be below or equal to the same one which in the previous one. So MASM will generate, automatically generate below or equal and so on. In case of this double word, signed double word, then this will be the same one, however it will use the less than or equal and so on. Unless you prefix one of the register operands with the S double word, here you can see we have used the signed double word, so it has used the, it will use the, so we did not mention here, previously we were using, as you can see here, here we are using double word and there is jump below or equal and so on. So it is using jump below or equal, so this is the unsigned jump when both the operands are registers, both the operands are registers. However, even if you use the result is S word, but we are not using any register with the here we do not mention any variable which is being assigned, like signed variable was assigned to EBX and so on, and we were using that in the expression. Here we are using only registers, but signed will be considered, or signed expression will be considered until and unless we do not mention S double word or SD word and pointer. So in this case it will automatically generate the code in the signed word, so then the signed jump will be generated. So until and unless you express, you write the prefix one of the register operands with the SD word and pointer operator. Otherwise, if you perform the normal operation without this SD word and pointer, it will consider them as an unsigned one. Now there is repeat directive. Here you can see there's a repeat directive. So in this repeat directive, what will happen in high level languages, we use sometime repeat, and there is a body of the loop, and condition is checked here in the until statement. So repeat and until, they are used in a pair. Now from this repeat till until, this code or this body will be executed once, whatsoever the condition is, either condition is true or false. But the case is different in while. In while, first the condition is checked and then the body of the loop will execute. Here the condition is different. So condition is at the end, so whole body must execute once. Then the next time or next iteration depends on the condition. If the condition is true, it will repeat. Otherwise, condition is false, it will do nothing. It will come to the next statement. So here, for example, we are using repeat and increment EAX. So we can use either call, or we can write decimal or line feed and so on, or we can use std out and so on, these statements to print these values for the EAX and so on. So here these are the two directives in the book which have been used here. So it will repeat until EAX is equal to 10. So for example, initially value of EAX is equal to 0. So this repeat directive will execute whatsoever the logic is. It will, once this loop will execute, so it will increment EAX. Then these two procedures, they are mentioned inside the book to print the values, value of the EAX, whatsoever the values in the EAX. So it will write the decimal value inside the EAX, and there is a carriage return and line feed, so it will come to the next line. Here, when it will come up to the until, it will check either EAX is equal to 10 or not. If EAX is equal to 10, then it will repeat. Until it is not equal to 10, it will repeat. If it is less than 10, so I think this should be, for example, EAX is less than or equal, for example. If until EAX is equal to 10, so I think it should be until this condition is true. For EAX is not equal to 10, then it will not repeat. So until EAX is less than or equal to 10, for example, so it will repeat again. EAX will be incremented. It will repeat until the value of EAX is less than or equal to 10. This previous condition was wrong, so I have changed this condition. So here you can see this is the high level directives like repeat and until, which we have used to generate the code for the to implement the logic of repeat and until and so on. Now while directive, this is the while and NW, while and NW. So here this is different from the repeat, that this condition is checked once. This condition is checked every time before executing the body of the loop. So move EX comma 0, and what will it do? It will check the condition first, and then the body of the loop will be executed and so on. So with the repeat directive, we use until, and with this while directive, there should be end while or NW directive and so on. So in this lesson or in this lecture, we discuss about the bit test instructions. Then we discuss about the conditional loop instructions like loop 0 and loop equal. So this loop 0 or loop equal will perform the loop, or it will execute or jump to the destination until unless if the ECX is greater than 0, and zero flag is equal to 1. So in both the cases for loop 0 and loop equal. However, in case of loop NZ or NE, it will jump to the destination if ECX is greater than 0 and zero flag is equal to 0. So it means the zero flag is not set. In that case, it will jump to the destination. Then we discuss about the block if structures, and we also in the block if structure, what we did, we have seen that how we can use if statement purely in assembly language. We have considered different expression formats, and in case of compound statement, we have used and or, how we can implement and or inside the if statement and so on. And also we saw the logical operators and conditional operators, less than, greater than, less than, equal to, greater than, equal, and so on. On the other hand, we have seen that how we can make this code more efficient if we are using the signed or unsigned, whatsoever the logic we are using, or whatsoever the operands we are using. So the main technique is just to make the code more efficient enough. Similarly, while and repeat loops. So in the while loop, we saw that we can implement while loop by using the pure assembly language, and also there was a logic like we can use while, and we have the condition, and also we have the and W or and while. And for the repeat, we can use repeat statement by using pure assembly logic. So this one is the body, and for the repeat we can use repeat statement or repeat directive and until directive, and there's a condition after this until directive here. And this loop or the body of this repeat will execute once, even if the condition is, this condition in the until is true or false, whatsoever the case is, but repeat loop will be executed once. So this is the end of this lecture, and inshallah in the lecture number 21 we will come with the new other topics in assembly language. Till next lecture, Allah Hafiz.